Hello, this is Yashasvini Razdan reporting for E-Ties. I'm here at Recode Kerala with Libin T, who's a scientist at C-DAC from Trivandrum. Thanks a lot, Libin.
Thank you.
So Libin, could you spoke a lot in your talk today. You spoke about the Vega processor. So could you just enlighten our audiences what that is exactly?
Yeah, the Vega is as part of a Digital India RISC-V program funded by the Ministry of Electronics and Information Technology. So we have built a series of microprocessors starting from the microcontroller class to a high performance embedded class processors we have built, and using some of the processors we have made some of the ASICs also. ASIC means it's a system on chip which we can use in different products. So the Tejas 32 is the first ASIC which is available right now, and we are using this as Tejas 32 in one of our Aries series of development board also, and it's an Arduino compatible development board with which all the academia and the industry can use it in their product development phase.
Where do Vega and Tejas stand today in the industry? We've got a lot of companies making RISC-V chips.
Yeah.
So where do Vega and Tejas stand comparatively?
Yeah. So the Vega processors are based on a RISC-V instruction set architecture.
Yes.
Yeah, which is open source, and
Yes.
anybody can do a processor development based on the
Yes.
RISC-V instruction set architecture. So our Vega, the particular processor which used inside this Tejas 32, it's a three-stage processor with a 32-bit instruction set architecture.
Okay.
So which is at par, when you compare the performance, which is at par with whatever available in the industry also. So the performance wise, when you compare the Cormark and Rystone are the normally people are using for benchmarking the processor IPs. So when you compare the benchmark of Vega with other IPs, it's comparable. Yeah.
How do you plan to increase the adoption into products for these particular chips, considering the competition outside in the market?
Yeah, so initial phase we have also faced a lot of challenges because people are already familiar with other instruction set architecture.
Yes.
And they were extensively using other development boards available in the industry. So when we came up with Vega processors and development boards in 2022, so people are a little bit hesitant to adopt this particular ecosystem. So now people are more aware about the RISC-V instruction set architecture and the development which is happening in the RISC-V domain. So people are ready to use the Vega processors right now, and many people in the academy and industry, they are buying the processor as an IP, and some people they are buying the Tejas 32 SoC also in their in order to use in their product designs.
Which brings me to the question, C-DAC initiatives are technically very sound, very strong, but commercial adoption is very low.
Okay.
So what is the missing link over here? Why isn't C-DAC with all its technical prowess able to convert all of that innovation into commercial success?
Yeah, so right now what we are doing is, so we are one side we are making a few reference design which industry can easily adopt and see whether the processors are meeting their expectations or the performance levels. So one way we are three SoCs are already fabricated using our 32-bit processor, 64-bit processor, and a 64-bit dual core processor also. And a few development boards and the SoC will be available in the market in the next couple of months time. So then people can use these development boards in order to test their applications and see it's compatible with their expectations or not. And we are also started aggressively marketing our processor IP, so that interested people, they can choose our processor IPs and they can build their own SoCs. So few people are already started working with us. So some of them are doing designs in the network domain. Some people they are are doing in the IoT domains. So it's slowly increasing, and we are also catching up.
With C-DAC here in Trivandrum and the Kerala known for its open source ecosystem, will we see open sourcing of silicon hardware IP happening with C-DAC support? Is it possible? Is it commercially viable?
Yeah, CDAC is also planning to, we have different methods of licensing our IPs. So for the MPW activities, that means for initial prototyping, we are also giving a processor IP as free, so that it's very viable for them to develop their product also. And whenever they are going for the large number of productions, so they have to pay the licensing fees at that point in time.
So how is like C-DAC decentralizing the product capacity to states like Kerala without compromising or diluting on innovation, like when or product quality, if I could say that.
So whatever activities which we are doing right now, right? So when you compare the processor IPs as mentioned earlier, so we are making sure that whatever products we are making, it's the performance levels are at par with whatever available in the industry. So right now only one chip is available for making it available for the commercial use. So the benchmarking are all numbers we published in the website also. So anybody can compare with our performance levels with the other ARM or other processors are available in the market. So in that case, we are not diluting any quality per se. So we are also trying to make best out of our capacity.
So how does C-DAC benefit from the Kerala product development ecosystem?
Basically, right now we are getting a lot of funding from the central government institutions. So, and mainly we are getting the manpower from Kerala. So we have a skilled manpower available in Kerala, which is their hard work and dedication supporting us for building all our processor variants. And in that way, Kerala is helping us a lot.
All right. Well, thanks a lot, Libin, for your insightful comments.
Thank you.